Here are the solutions to the first quiz for the fall of 2015. In problem number 1, we're asked to compute a limit. If we try to compute this limit by substituting directly into this expression, we'll find that we get a 0 in the numerator and a 0 in the denominator. That's an indeterminate form, so we need to do some algebra to simplify this expression before we can substitute h equals 0. Here are the calculations. 4 plus h all squared. We square the 4 to get 16. We multiply the 4 and the h and double it to get 8h. And then we square h to get h squared. And finally, subtract off the 16. Once we do that, the 16 and minus 16 will add out, and h remains on the other two terms, and we can factor that out. Once that's been factored out, the h in the numerator and the h in the denominator can be canceled, leaving us with 8 plus h for an expression. Plug in the 0 then for the h, and we see that the limit is 8. So your solution on your paper should then look something like this. In problem number 2, we're asked to compute some limits by looking at the graph of y equals f of x. In the first problem, we're asked to compute the limit as x tends to 2 from the left. So our x values should approach 2, but from the left-hand side. That means we'd be following the curve along this portion, and those heights get close to 2. So the limit as x tends to 2 from the left of f of x is 2. If we take the limit as x tends to 2 from the right, we'd be following the curve along this portion. Those heights get close to 3. So the answer here is 3. Finally, the limit of f of x as x tends to 1, this is a two-sided limit, means that x's should approach 1 from both the left and from the right. If we do that from either direction, we get close to this point, which has height 1. Your solutions then should look something like this. There's really no explanation needed. You're getting the information that you need by looking at the graph. In the final part of the quiz, we're asked to consider an equation of motion. The height of a ball is given by 40t minus 16t squared. We're asked to compute its average velocity over two different time intervals, starting at time 2 and lasting for 1/2 second or 1/10 of a second. And then we're asked to come up with our own method for estimating the instantaneous velocity at time t equals 2. Average velocity from 2 to 2.5 seconds can be computed by subtracting the height at 2.5 seconds from the height at 2 seconds, and then dividing by the elapsed time. The height at 2.5 seconds is given by this calculation. The height at 2 seconds by this one. We'll subtract those and then divide by the elapsed time of 1/2 second, and we get 32 feet per second. In the second part, the calculation is almost identical, with the exception that we're working on the interval from 2 to 2.1 seconds. Here are the calculations. We come up with minus 25.6 feet per second. You should notice that in both of these parts we're getting a negative velocity. What that means is we're already into the portion of the flight of the ball when it's returning to Earth. So as time increases, the height of the ball is decreasing, and a decreasing height will then give a negative velocity. We also notice here that the average velocity over 1/10 of a second from 2 to 2.1 is substantially less than the average velocity from 2 to 2.5 seconds. The reason for that is simple. When the ball reaches the apex of its flight, its velocity is for only an instant 0 feet per second. As it continues toward the Earth, its velocity in absolute value increases the longer it's falling. It's been falling only a short time here, so that velocity is smaller in absolute value than the velocity here, as it's had longer to speed up on its return back to the ground. In the final part of the quiz, we're asked to compute the instantaneous velocity of the ball when t equals 2 seconds. You can use any method you wish, but for the methods that we've learned in class so far, we don't have much choice except to just simply use a very short time interval, say from 2 to 2.001 seconds. The calculation then is essentially the same as in the previous two parts, except that the time interval is very, very short. Here are the numbers that we need to put into the equation of motion, and when we do the calculation, we find out that we get minus 24.016 feet per second. It would be a good guess then that the velocity at 2 seconds is exactly minus 24 feet per second, and if you use the methods of the calculus, you can show that that is in fact the case.